Hello, this is a quick video of a little job I've been meaning to do for ages. Have you ever noticed that when using handheld power tools on metal, as the drill breaks through, you seem to be snapping an awful lot of drills? Happens to me regularly and is very annoying. If you look at the machine, all of the modern ones feature end float on the drilling spindle. Why? Because they have a hammer action, and when you set them onto hammer, you need end flow. Well, guess what? I never use this on a hammer action because I've got a proper SDS machine rather than wrecking this little thing. So what's that got to do with breaking drills all the time? Here's a large drill which should show with some greater clarity. Anyone who uses machine tools will understand this straight away. The chisel edge in the middle of the drill is something that's needed for the drill to push into. So the moment the drill breaks through the workpiece, you don't have this chisel edge for it to push back on. It's free to snatch greedily, grab into the workpiece, and something's going to give. And on a small drill bit in a handheld drill, it will be the drill bit itself that gives and it shatters. Making that problem much worse on a handheld drill is this end float. And in most cases, that end float is for a function that most people do not use, the hammer function, which has been largely replaced because most people have got an SDS impact drill now rather than the awful hammer feature that's on these that kind of does but isn't ideal. So I'm doing a little trial. Here's my Makita HP271 percussion drill, which I use almost exclusively on metalwork. This machine has come apart for another repair, the slipping clutch, which I've burnt out from, guess what? It's slipping. Why? Because it catches as it breaks through on larger metal jobs. I do use this machine for things way in excess of what it's supposed to be designed for. I'm regularly using 3/4 inch blacksmith drill bits in this, which I know it's not supposed to do, but we do these things. And whilst the machine is apart, I've taken some measurements. This is the end of the chuck spindle, which, as you can see, has the end float on it, which I do not want. And in the end here is the hole into which it engages, with on top the lockout for normal drilling or hammer drilling. I've made this little disc out of some bronze, which is the same diameter as the shaft, and with some calculations should eliminate the end float. To save it popping out and to save uncertainty, I've made this so that it fits into the recess with the drill set in hammer action. So the drill control is now set on hammer and will not slide out of hammer, but it should present a smooth drilling action when these two are put together. I'm giving this a trial fit first, and if it seems good, it's then going to come apart for some fresh grease. So the drill's back together, and there's maybe a couple of thou of end float. This looks more because this part of the chuck is rotating body, but there is movement in there. Still rotates freely. I'm going to see how this performs on a drilling job I've got to do tomorrow, but I can't see how it's going to make it any worse. And if it's successful, I'm going to try and roll out this modification on my other handed drilling tools.